The following is brought to you by Total Seal Piston Rings, the leader in ring seal technology. TotalSeal.com. Hello and welcome to another edition of Hidden Horsepower Live. My name is Joe Castello, and we have got another fantastic show for you. If you're listening to the audio-only podcast, you are going to love this as well, as we are going live to Comp Cams, where our own Lake Speed Jr. and, of course, Billy Godbold is joining us. Gentlemen, how are you?
Well, it's Memphis, Tennessee. The train's not going by right now. Now, it could come by later, right?
It'll be here, yeah.
It'll be here.
Yeah.
So, hey, can't ask for anything better.
No.
It's not 100 degrees today.
Yeah, right, which is kind of weird. We haven't had the hot summer yet.
Yeah.
It's coming in August.
It's coming in August?
Scheduled,
yeah. Okay.
Yeah.
I went for a run this morning down by the river, and it wasn't like just killing me.
Yeah, no, the mornings have been really good. I don't know what's going on. We haven't had the rain we normally have, so it's only like 100% humid. It's not up to 110, 120.
Exactly.
Yeah.
So.
I haven't seen any catfish swimming through the air.
Not yet, at least.
Not yet.
Yeah.
As you can tell, this is going to be a very fun show. We're going to learn a whole lot about camshaft technology, but you guys have spent a lot of time working together in the past. We can tell there's a great chemistry, a lot to learn on this show. You
have your work cut out for you today, Joe, to keep us two squirrels on track, because this is dangerous.
No, we'll chase anything, absolutely anything.
Yeah.
You know, Lake and I are kindred spirits in that we love measurement technology. We love being able to take something we understand conceptually and go, how do we put numbers to it? How can we make data-driven decisions? Right.
Yes.
You know, get past opinions and get toward facts. So this is a lot of fun.
Oh, trust us. Just today, walking down the halls of this building, me and him together, the looks in people's eyes are like, oh God, those two are together again. No.
Yeah.
Trouble is happening.
Yeah.
Because like Billy said, we are kindred spirits in that you have to have data to make decisions.
Right.
Otherwise, you're just, like you said, voodoo magic. You're guessing.
Right.
And that was the old days, is you threw a bunch of stuff at it. You really weren't sure what made the difference, and maybe things ran better. So you're like, oh, well, whatever my idea of that was, maybe that was the good part of it.
No, and you'd hear it from the old engine builders. You know, I think that, you know, I've heard a couple of seminars that Ed Skidarian did. And it's amazing how he could actually imagine what was going on inside the engine. I heard one of the old-time cylinder head gurus talk about, imagine you're sitting on top of the piston with the piston going down and up, and visualizing the airflow around the valve and trying to think what happens as the flame starts. Right. But they had to do it all with imagination, right? Now it's like, you know, you hear these guys go, well, I think that at this point the pressure in the cylinder is less than the pressure on the intake port. Well, today you can actually take and drill, put a pressure gauge, high speed, National Instruments, the Kinsler stuff, go in there. ABL has all of it. You can actually measure all these things that these guys had to guess about. Yeah. And that's a tremendous change in engine technology that you've seen over the past 15, 20 years.
Oh, think about it. It's like the wind tunnel for a car.
Right.
People used to make all kinds of body style changes, and you weren't really sure what they did. You go to the wind tunnel, find out, okay, this one's better.
No, and it's kind of cool how you see this works back and forth. Like, they would say, you know, Dale Earnhardt wore an open face helmet, not a wise idea, clearly, because he said that he could feel the air buffeting his facial hair when he was in the draft and know how the car was performing. You know, when you think about that, from going to trusting the mustache, which that was truly an ordained mustache. That was a gifted mustache. But going from following the mustache to now you see people doing everything. You go in CFD, you see what the model should do. You go back, you go to the wind tunnel, you find something else, you make your model better, and then after 2 or 3 iterations of that, these guys can get these cars just amazing. Right, exactly.
Again, it's all about having that process to acquire the data. Do that. I mean, you and I spent how much time figuring out how to really do a proper cam wear test for oil. So then all of a sudden, now you dial it in. Oh, it's amazing what you can do.
Now, we were do a different lifter design, and the guys were going, hey, let's try this other profile. I'm like, guys, this thing Lake and I did, we literally have data off 100 camshafts. We're not changing the cam profile. We've got tens, if not hundreds of thousands of dollars worth of data off what this cam profile ground on this machine with this surface finish and this taper with this oil, what it runs like. So why mess with that?
Right.
You know? So yeah, it's really, we took all the parameters out. We took the, a lot of the things, like you see a camshaft, you take a flat tap cam out of a box. It's a black color. And people go, well, what's that black color? And you'll hear, oh, that's Parco, that's phosphate, everything like that. Well, that's kind of really what it is. It's an acid etching that allows zinc phosphates and phosphates to grab the top of the camshaft, and that creates the lubricant and the breakdown to establish that wear pattern. And what we found out, it really is a wear pattern.
It does. Yeah.
It really does conform. The lifter and the cam become dancing partners. But like on all our cam tests, we took the Parco out, the zinc out, because we didn't want to see what that uncontrollable, it's hard to control that. Take that uncontrolled variable out and do it without the Parco. So when we do wear tests here, we do them without the Parco, knowing nothing but the Parco just helps expedite the break-in procedure.
If you can make it work without it, it will work.
Absolutely work with it.
Exactly.
Absolutely.
Exactly.
Yep.
So anyway, like I said, Joe, you already lost us. We already went down one rabbit hole. So that's the first. There's probably 10 more to come.
Yep.
Do I hear a train?
Yeah, we're going to get it.
There we go.
I told you we'd get the train.
Oh, yeah. So if anybody's ever been here to Memphis, especially the Democrat at Comp Cams, you know that there's a train right out that wall. And here it comes.
Yeah, the door back here, if you open the door, you can't touch it with your hand, but you can touch it with a broomstick. Don't ask me how I know.
No, it's coming through. It's coming through.
Oh, yeah. Dude, hey, it's liable to come through the wall, so don't,
This one's not bad.
Right. If
this is really not bad.
There's two tracks. There's a track that's closer to us, the track that's furthest. Because my chair's not shaking, I know it's on the further track.
Exactly.
Well, that would be good for the numbers, guys. It wouldn't be good for Nick. We'd have to get Keith Jones to carry on the tradition. But boy, it would make the news.
Wait. So one thing to kind of pick up your point about the old days without having data.
Yeah.
Is that one of the previous episodes not long ago we had Larry Wallace on.
Yeah.
And Larry was talking about the first Spintron they built.
Yeah.
They didn't have any laser measurements, nothing. They just listened. They said we could hear it when it went bad.
Yeah, no, and you absolutely can. It's one of the things that, I don't know if I can twist the camera over here, but we're about to put in 2 new rooms here that we've had big rooms built for our Spintron, and they have the insulated walls in them. And so the idea there is we can put microphones in there and try to get a clearer signal of what's going on with the audio. Because, one of the things we've been doing is we'll put a load cell under the valve spring.
Right.
And we'll put strain gauges on the coils themselves so we can measure the stress in it. But what's hard to pick out is when the coils start to hit one another, they'll make a really high-pitched noise. So, y'all, I'm going to get made fun for this forever, but you'll hear it go, you hear that change of pitch. And you'll hear it sometimes like on the NASCAR in-car cameras, and you'll hear the pitch change. Well, a lot of that pitch change is when the coils, because you have 5 active coils, when they start clashing, all of a sudden the tone will go up 2 octaves.
Okay.
And when that octave change, that's the coil clash. So one of the reasons to go ahead and spend, a couple $100,000 on real good soundproof rooms is not only so you don't drive your guys crazy when you're trying to build an engine next to it, but also so you can put microphones in there and really try to pick out some of the frequency analysis of the sound the engine's making as it's going. And this is without, Joe, you may not know this, but the Spintron doesn't have any firing in it. So you don't have all the exhaust pulses, you don't have the piston slap, you don't have that.
No combustion.
It's a dummy crank, it runs around, but it is running the valves just like it would in the real application.
Yeah. Well, if anybody wants to know more about it, you can go back to one of the previous episodes where at Ben Strader's, and Ben actually goes through and shows a little bit of it.
Yeah, that's a great episode.
So you can go back and do that. So here's the bad thing. You say you spent all that money on that cell. George Bryce, our good buddy. Yeah. Which, George, if you're watching, hey had George. A great time this week hanging out with you a little bit.
Yeah.
His new shop is an old music studio in Hendersonville.
Yeah.
And it's this truly soundproof room. And he's like, I got no idea what to do with it. It'd been a perfect Spintron room. Who knew?
Right. Dang it. I will tell you that one of the things, we tried blankets and different things like that. And if you want to be able to run endurance testing and dynamics testing, you can't do it with normal soundproofing because you get this oil mix. Even though on top of the deal, we have all this filtration. We have all this airflow. But still, when you run the oil for durability test, the oil can be 250 degrees.
Oh, yeah.
You know, it's evaporating the whole time.
Springs are hot.
Yeah, people don't understand that. Like when people think about motor oil, they think it's all about lubrication. And to be honest with you, probably about, 30% of the heat rejection.
Some is more as 40.
Right. 30-40%, especially from the Valvetrain, comes from the oil, not the water. A little bit of the heat goes through the cylinder head from the valve spring.
Well, think about it. The spring's not being cooled by water.
Right.
It's cooled by oil.
Right. And one of them sitting on top of, instead of sitting on a water passage, the exhaust, half of it's sitting on top of an exhaust port.
It's really hot.
Yeah. You know, to make power, that's something about heat engine.
Volumetric efficiency?
Well, you know, the whole
air density?
The energy comes from heat.
Yeah.
It's a heat engine.
Yeah, kind of.
Without heat, yeah. PB and RT, the T is what makes the P.
All right.
Yeah.
Guys, you're right. I have my work cut out for me here, but I'm going to jump in every once in a while and just make sure everybody out there watching on the Total Seal Facebook page and YouTube channel and our Hidden Horsepower group, and I've shared it on WFO Radio as well. Number one, if you've got a question for these two, you can put it in the comments section. And this is just going to be a wide-ranging conversation. We're going to cover a couple of topics. Now, obviously, I want you guys to talk about what is the goal of this conversation? Like, what area of knowledge would you like to advance? Certainly, we've got Billy, and so camshaft technology, but what about it? Like, what are the misconceptions? And I would imagine, just like the other stuff we've spoken about on Hidden Horsepower Lake, there are a lot of people doing what they've always done just because it's always worked, and maybe missing out on some new technology that has evolved that they have yet to try.
Well, the reality is, and this is, I feel like I'm beating the dead horse over and over again, because we keep talking about it all the time. Surface finish.
Yeah.
It is the thing that we had a conversation this morning with Scooter and the guys over at Driven, and they're like, so what's the biggest thing you've learned being at Total Seal? I'm like, surface finish is the variable that no one was monitoring.
And it's the most important one there is for sealing.
100%.
Right.
I mean, we've learned the lessons the hard way with the camshafts.
Right.
What that surface texture and geometry is everything that was the biggest thing. But so going back to all the cam testing we did,
right.
The biggest thing we had to do overall was control that surface finish. So part of the Parco taking it out was getting back to controlling the surface finish. So we had the right taper, we had the right surface finish, and you had to measure pre-test, post-test. Every single time you're back with the profilometer checking and checking and checking. And so it's load carrying, it's sealing, and that's really where the two of us, our worlds collide, is surface finish technology. And it's not new to me and you, because we've been doing this for years now, but out in the field, that's where it's just still something that's coming on new, that people are just kind of really catching on. So I think that's always a point of top conversation, is to talk about surface finish and realize it's not just about piston rings.
No, it's about every component in the engine,
right?
Especially anything that has interaction with another component.
Yes.
Yeah, when a component's rubbing on another company, rolling, rubbing, sliding, however it's interacting. When two parts interact, they don't touch like you think they will touch.
No.
You know, that there's always this interaction between the peaks of one and the peaks of the other, and how much you can spread out that load, whether it's a ring or a camshaft and a lifter. And today that's more important than ever, because you look at, like in NASCAR, and the whether it's the Cup Series or the Spec Motor Series, like the Truck Series, you see it now with the SRX. These guys keep on pushing mileage out further and further and further. So, you know, what used to be 1,000 miles would be considered a long time when you were a Gibbs.
Oh, God,
like, hey, this part will go 1,000 miles. Great. They won't even touch it if it won't go 5,000 miles in a cut motor. The durability test that Ilmore's doing on the Spec motor is a 20,000 race mile durability.
Wow.
And so it's things that right now, this is getting to the point where it's actually surpassing the GTLM, the IMSA, the 24 Hours of Daytona, 24 Hours of Le Mans. That some of
were the toughest, hardest things.
That was the hardest thing in the world. Today, you have circle track motors that are like that. And you go, okay, Billy, well, that maybe matters for them, but how does this matter for us? Well, a good friend.
The guys with 1,200-pound open spring pressures, which is a lot of them out there anymore.
It totally matters because you can't have the camshaft spitting chunks of cam or lifter into your oil system and maintain ring seal.
No.
If you don't have ring seal, you don't have power. If you don't have power, what's Warren say? That if you can't
tune it up if you blew it up.
Right. So if you're on the trailer and they're not, you have lost the next round, regardless of how fast you think your stuff was. But no, it matters for just about everybody. I mean, today you see people with 500 horsepower to 700 horsepower, normally aspirated engines, basically almost daily driving them.
Oh, that's the most blasé thing in the world.
Right.
10, 15 years ago, that was, oh my God, that's a cup engine.
And the turbocharged guys, 1,000 horsepower, 900 horsepower daily driver for a blower, that's not a big deal anymore. So you see the Power Tour stuff, that's 2,000 plus horsepower.
Right.
So basically what we've done is we've changed the way we dress we've gone to all new grinding wheels. You know, when I started, we had like 5 or 6 Burco grinders. Even a few years ago, when you went to Total Seal, we still had 12 Burco manual grinders.
Oh, I noticed today walking in here.
Yeah, today.
All those Burco grinders are all gone.
Right,
they're all Landis's.
Right, there's Landis grinders out there. We've got 8 Akuma CNCs. We've got 2 Landis CNCs. We're doing like 95% of our grinding today with CNCs. And what that allows us to do is run a whole new grinding wheel. Now, these new grinding wheels, they're the CBN grinding wheels. They're done with a crushed diamond dress. We can change the whole profile of how we do it. So if you imagine now when we grind a camshaft, we have a very slight crown on it. And
on the roller cams.
On the roller camshafts. Right. And on the wheels that the roller cams run against, they have a slight crown on it. What we saw with the Ilmore thing is the biggest interaction is actually the edge of the lifter wheel. Because you imagine the edge of the lifter wheel where you have a crown ground on this, but you have a chamfer here, there can be a real sharp corner there. And one of the things that people need to know with every failure, nothing just blows up in an engine.
Oh, yeah. I think there's a guy I met one time that said every failure begins at a micro level and then propagates to a macro level.
Right.
He may be a nuclear physicist that went to Florida State. Yeah. I don't know, but
I know that guy really well.
You know that guy?
Yeah.
You see him in the mirror once in a while, don't you?
He hangs out with my wife all the time. And I'm cool with it, which is kind of weird. But yes, that whole idea of every macroscopic failure, every big failure you see, starts microscopically. So if you go in there, like I saw a valve spring break one time, and I go and look under a Zeiss microscope. CSI, I see his fingerprint.
Get out of here.
The guy had a different pH level. He was kind of a salty guy, you know, and when he touches a valve spring, it's like, dude, I'm sorry, you're going to have to wear gloves when you touch a valve spring. He goes, what do you mean? I'm like, seeing this picture, digital picture, and you can see when I zoomed way out, there's his fingerprint, and as you zoom in and in and in, you see these little rusty ridges, and the failure started right there on the rusty ridge. You know, so, you know, you think about that a valve spring is nothing but a torsion bar that's wrapped up. And because the outside's got further around, the inside has less. The inside's the stiffer torsion bar, and it has more stress on it. So you can imagine if he took his double spring apart, measured the inside, measured the outside, did all the good stuff. When he put it back together, not having any gloves on, you know, you just intentionally put your finger down in there, right? And so when he got in there and looked, you could see his fingerprint on there.
And it was the acids that solved on his finger.
Just a little bit of orange, and you look in there and you go, okay, that's a fingerprint. Okay, it failed in this fingerprint. So, I mean, I don't know. Just gloves or better AC in your shop. I don't know what to do, but you know,
that's amazing. We got a question out there, guys, on this topic. What surface finish parameters are you looking at on the cam lifter interface? And this is kind of right in the wheelhouse you're talking about. So, what's optimal?
I bet you know.
I know a little bit. So that was one thing you said before is like, so on the flat Tappet stuff, obviously you have a taper.
Right.
Because the taper has to match the crown so that you have that contact area and it spins. And and like you said before, we see with the pre and post profilometer measurements, we could see that mating.
Right. The camshaft will eventually become slightly concave.
Yes.
Yet on our roller camshafts, because we want those, because if you can imagine, if you hold your fingers like this, and I push down on it, like if I hold them flat, it tries to tear apart.
Well, it was the flatbed truck analogy you told me that made the most sense.
Right,
think about a flatbed truck going down the road, no load on it. What is it?
Arched up.
It's like a bridge, arched up. But when you put the load on it, it comes back flat.
Exactly. So
to hold the load so it doesn't sag and break.
Just like one of those aluminum flatbeds, we want to make the roller with a slight convex so that when it's loaded, it pushes down. And we can see it after a spintron test. That profile, it'll be, when it's just right, you'll start to see wear across the whole surface. If you have too much crown, it'll be like a narrow strip.
Right.
If you have too little, you'll see a lot of edge digging in. But so that contour is our first thing we look at. Everybody goes, well, second thing you got to look at is RA. Nah.
You got two RA heaters right here.
Right. The first thing we really look at is the RMR, which is a material ratio. The common term for it is bearing area. And this goes back, I had this long talk with a guy that you know over, most people in our industry don't know this, but the diesel world is probably the most competitive engine world in the world.
Oh, yeah.
It's what my son studies. It's what we've gleaned more from probably any other place. Cummins is probably the best engine company in the world. And I got to hang out with the R&D director of Cummins.
Yep.
And we're going, okay,
buddy,
you got to go, okay, well, what steel are you using? And he told me, and I'm like, scratching my head. I'm like,
that? You're using that?
Using that? What's going on? And he goes, okay, Billy, tell me with what you've done, where have you gone from? What's your ultimate tensile strength gone from? And man, I poked my chest out. And we went from 255 to 278 KSI. He goes, well, what type of percent change is that? I'm like, real quick, about a 10%. He goes, well, Billy, what would you do if I told you I made my wear go down by 300%?
Fall out your chair.
I'm like, well, bad steel for a camshaft's over 200 KSI. The best steel in the world is like 360 KSI. There's not 100% change. You can't do a 300% change. He goes, yeah, but what if I could spread that load out over 3 times the surface area?
Yep.
He goes, what is your bearing area? And I'm like, I thought it was big stuff. He goes, I'm over 30% at 20 millionths of an inch, 20 microns. He goes, nice. I'm at 96.
Yeah.
Like, ooh.
Yeah, it's the idea of push-ups on your fingertips versus your palms, or maybe in that case, push-ups on your two fingers versus your palms.
So between what we did with the grinding wheel, when we got in here, and sorry, we're a working shop, so you hear garage doors, you may see a car here pulling in and everything like that. But between changing the RMR with the grinding and then going to the micro surface enhancement process, we were able to bring that up from 30% to we run over 90% all the time. And even more so, what was down at 10 millionths of an inch, the lighter loaded condition, we had to bring that up from 15% to nearly 50%.
That's awesome.
So we were able to get that same thing. We were able to move 300-400% improvements.
So what does that translate into in terms of surface finish values that someone might understand?
Well, to get the surface finish, if you go back to RA, to get your if you're not down around 10 to 15 RA, you're never going to get into the 50, 60, 70%.
You can't get there,
Right. But that's just with a normal RA. The nice thing is when you go through the micro surface enhancement, you're basically like plateau honing a camshaft.
Exactly.
I describe
it's taking those peaks and it's bringing it down like this. So you still have those valleys, but you've got that more bearing area on top.
Right, but you'll see people you can't polish goodness into a camshaft.
No, you can't.
You'll see people try to do it with the final polish. And if you polish it enough to change the bearing area with the camshaft that's not very good, you'll get all kinds of waviness. So back to your contour analogy, you can try to polish one, you can make it look gorgeous, but it will have horrible waviness, and then that'll put peak loads on those parts that have the peaks of those waves.
Right.
The difference between waviness and roughness is waviness is low frequency, roughness is high frequency.
Yep.
Right. So, sorry, I may have confused that, but our RAs, when I started, we were like 24 RA max. Today, off a grinder, a rough camshaft would probably be 15 RA max.
Okay.
But after it goes through the MSE, it's going to be, it's probably going to be down around 6 RA.
Right.
But really, the RA
that's not what matters.
I couldn't care less. The RA is just kind of the byproduct of getting the RMR, the bearing area.
Yeah. Your material ratio curve looks like this, not like that.
Right, exactly.
So there's a whole lot of stuff that'll give you one look like this.
You can make
Trying to get it like that is the key.
You can take a straight line with little spikes going up, flip it over, have a straight line with little spikes going down. For rings, you definitely need those valleys for holding oil.
Oh, yes, sir, we do.
But if you flipped it the other way, it had the exact same RA.
Yes, it would.
So, you guys normally do it with the RPKs.
Yep. RVK and RPK are two biggest, right? You don't want RPK, you need RVK, because obviously the ring, you're trying to hit those peaks, you don't want that, but you need that valley to hold the oil, because like with the ring, the oil is not just a lubricant, it's also the gasket.
Right.
So you got to have that.
Yeah, in the camshaft world, instead of the RVK and RPK, we look at RMK and RMV. Okay. And that's a mean valley height and a mean peak height.
That makes sense.
Instead of the skewed version of the K family.
Right.
But you guys need it because a camshaft treats 4 narrow valleys, equally spaced, exactly the same as one valley that's 4 times as wide. A ring won't treat it that way because the ring will actually fit more oil in that one big valley than it will in the 4 narrow valleys.
Yeah.
To me, the valleys really don't hold oil. They take away my bearing area.
Yeah, for you it would be.
Right. So I care about the means. I care about the M families.
Yep.
You care about the K families. No real difference other than for somebody like Mark Malberg would tell us both about this.
It does. Both.
Right.
You're dummy, shut up. Let me tell you how
like how this really works. Right.
Which, by the way, for people who are interested in this conversation, he has a brand new book.
Yeah, his book is awesome, guys. If y'all can get it, if you look up, what's the name of the company? It's
where's my backpack?
Metallurgical Technologies.
Yeah, wait, I'm gonna grab my backpack. While you keep talking, I'm gonna show the book.
But a good friend of ours, Mark Malberg, he's up in Indianapolis. He does a lot of work for OEs and engine and stuff like that. He also does a lot of work for the consumer's electronics world. So, probably your cell phone uses his.
Yes.
So here's his book.
That's the book.
You want that book?
Yes.
It's the Surface Texture Answer Book.
Yep.
And Mark's a good friend of both of ours. Super good guy.
Incredible information. Even just like this page alone.
Yeah.
For honing.
Yeah.
For cylinders, like this page alone is worth the whole price of the book.
Oh, absolutely.
Also, one page, you're like, oh, my whole life just changed. Just by reading one page.
And I'll tell you that really, there's been a couple of times in my career where we had to really change our way of looking at things. You remember when the motor oil world changed.
Oh,
when
yes.
You got into racing.
Yep.
You could go and buy a bottle of Rotella and on the shelves at Walmart, come back 6 months later, buy another bottle of Rotella. Bottle looks the same, specs look the same. Come back a year later, buy the same bottle. The specs have changed, but the bottle looks the same other than this. Pour them out, send it, do a chemistry analysis, and none of them were the same at all. And the Rotella stayed more consistent than any of the automotive stuff. So, Lord help you if you got something
you're chasing all these variables that you don't even know were variables.
Right. So when that happened, we had to learn a lot about surface engineering. Mm-hmm. We got our nitriter, we did all this. There's been times where we really had to get it. If I'd had a book like that, if I'd had some tools like this.
Yeah, to have this book to understand what the profilometer in this thing, this is the coolest thing in the whole world. This is nowhere near as nice a unit as the Zeiss unit you've got in the QC department. But the cool thing about this is it goes in my backpack everywhere I go. Right.
When somebody goes, hey, my bores look great. And you go, really?
Let's go find out. Yeah.
Right. And that goes back to the whole thing we started about. If you can't put numbers to something, you really don't have anything more than just a guess.
Right. That's all it is.
Yeah.
All right, Joe, you got any more questions or anything else? Because I know that was rabbit hole number 2. That was a pretty deep one too, by the way.
I think it was great, and that's why people are logged on and subscribe to Hidden Horsepower, the podcast, and are liking our Facebook page and sharing this right now. This is not so much a question as well, it's a question, but more about supply side for Billy. Are you guys having supply chain issues? Like, why does my engine guy keep having problems getting everything I need, from springs to cams, et cetera, and so on? I think the answer is it has to do with the global supply chain stopping and then restarting, but I wonder if you have a more specific answer.
Well, I think it's a bigger deal than anybody could ever understand. This has been one of the unique times in our lives, because as soon as all the shutdowns happened, everybody had to be ready for
the worst
case scenario, right?
Mm-hmm.
Nobody got the idea that, hey, people are going to be locked up in their houses. They're going to see their hot rods. They're going to go to work on them.
Right.
So while we had a lot of stuff in production and everything, we weren't coming into work in full shifts like we normally would.
Exactly.
We weren't running 3 shifts. We weren't running. And then all of a sudden, it kind of dings, the lights come on. You go, hey, people are buying things at a record volume. And as soon as you do that, you try to turn everything back on and go to full throttle. And
it's like your Spintron.
And
once it's out of control, it's out of control. You're behind it.
We just blipped the throttle for a few weeks.
Yep.
I mean, literally, the only day I missed work at this location because of COVID was Good Friday of last year.
Okay.
That's one day that I normally would have been here for a half day that I wasn't here. But, our shop did have to shut down. We did have to change protocols, things like that. But at the same time, as we turned on the spigot, I think everyone else turned on the spigot. Steel lead times that used to be 2 weeks, all of a sudden they became 3 months. All of our manufacturers, because a lot of stuff we piggyback on from the OEs.
Right, exactly. That was a big hit that people, I don't even understand the industry, that so much of what supports the aftermarket is the OE demand for either the raw material or the blanks or whatever that ends up being this. And when those guys shut down, that wave just ripples.
If you have a cast iron camshaft that was poured in the U.S., it was the sand that they use all comes from the shore of Lake Michigan in Michigan. So every bit of it comes from Western Michigan. More than that, it all comes from a little town called Muskegon.
Right.
Every flat tappet lifter and every flat tappet camshaft is poured in Muskegon, Michigan. They have this governor in Michigan.
I think she may be on the news.
Yeah. You hate to think about how people felt about her, but if you're our industry, you kind of get it.
Right.
It's like she shut the state down. I mean, just absolutely shut it down. So, we can't pour the iron any place in the U.S. other than Michigan. And so if Michigan's shut down, iron is shut down. In trying to establish you start trying to go, can we figure out some sort of network outside of the U.S.? Well, you go, hey, well, these guys in Spain do some of it. Spain gets the COVID. They shut down.
Right.
You're like, well, these guys in India, they do a pretty good job of it. Everything. They shut down. The guys in Turkey, they shut down. Guys in China, they shut down. So even though everything we've ever done has all been U.S. sourced, you'd think, okay, well, Billy, if you can't get U.S. sourced, can you get sourced someplace else? Some of it's really, really hard. And plus, you've got to do all the qualifications. So really, we need some of that to open up. Honestly, as much as we talk about flat tappet camshafts, I don't think people get this. Not me or anyone in this industry. There's not a single engineer who would work here who would put a flat tappet camshaft in an engine unless it was required by rules.
Oh, it's the flat tappet camshaft is the 5/64th, 3/16th spring package.
Right.
It just shouldn't exist anymore.
Right.
It still does because there's rules that mandate it, but the technology, we've come so far. I mean, anyone that's watched Andy's podcast has heard me say. It's like we're buying a Nokia brick phone, but we have the option for an iPhone, and we're just not choosing it.
And I think the sometimes the flat tappets are more like the old payphone. They're not even the brick phone. You know what I mean?
Yeah.
You know, that people. I had somebody go, well, Billy, you know, the OE's made hundreds of thousands of these, and I was lucky because he was actually an OE engineer, and I had some fun with him. I said, how much do you think the flat tappet cam and lifters cost GM, Ford, Chrysler back in the day? And he was pretty close. He's like, probably about $20, $30. I go, now you know that they wound up spending 5 to 10 times as much. What is the head of a truck line going to tell you if you add $1 to his million pickup trucks? He's going to try to kill you. Okay, now try adding $100 to each of them. GM, Ford, Chrysler didn't go from flat tappets to rollers because of emissions, power, anything like that.
And it wasn't because it was cheaper.
It didn't do it for cheaper. They were willing to spend $100, $200 more every engine because the warranty rates from flat tappets were so high. So if you made that decision in 1987, 1985, 1983, to spend $100 more on an engine that probably didn't cost them $600, $700 to begin with, can you imagine what the failure rates and what the costs they were incurring? So really, the roller camshafts are just the way to go from a warranty standpoint, from a failure standpoint. There is no way to get around that. You're going to have failures if you build enough flat tappets. So going to a roller camshaft is absolutely just the way to go.
Oh yeah, and look at it today. The modern ring packages, you can get a 1 millimeter top ring as just an OEM package.
Oh, absolutely.
All the time. So it's like, why would you build an engine? That's all the guys the other day, August, one of the new guys at work, I was like, hey, if it's a naturally aspirated engine, it's a 1 millimeter ring package. Don't put anything bigger in there.
There's
no reason. Because that is the big one. The 1 millimeter is the big one.
The 1 millimeter is what I have in my. I have a little road race car I play around, a little BMW with the LS motor. Run these 12-hour races. Yeah. For 12-hour races, I'm running the 1 millimeter stuff in there. It's not like a 24-hour stuff you'd run the 1 millimeter. There's nothing that you would.
The motor Schaefer's has got 0.7s in it.
Right.
And it's run thousands of dyno pulls.
Right.
So it's like you don't. If you're not making gigantic power. Well, you don't need the gigantic rings.
Well, you've seen the 900. When you left Gibbs, they're about 900 horsepower engine back then.
Yep.
I'm sure they were under a millimeter at that time, and those things would go.
Those were 0.7s.
Right.
Then
at 950 horsepower.
Right. Yeah. So you put a 0.7 in a 500 horsepower motor all day long.
Huge. Yeah.
You know, I mean, think about it. There are guys who have pro mods. They're making 3,000 horsepower.
Yeah.
They run an 043.
Right.
So you don't need a 16th ring. I mean, my God, you do not need a 564th ring package.
Right.
There's no call for it anymore.
And he was asking something to circle way back. Two things to think about that I wanted to make sure to mention is one is that every engine is a package.
Always.
I think people get caught up in trying to find the best cylinder head, the best intake, the best ring pack, the best everything is a package. So it's been one of the coolest things is the synergy of the Edelbrock group, Comp Cams, Edelbrock coming together under this one umbrella, is in all the cylinder head, intake manifold, camshaft stuff. All that stuff's getting better, and they're dancing partners. All this stuff has to work together. Other thing, you really think about. I had a guy, a friend of mine and yours builds. He builds some NASCAR motors, but he also builds motors for Saturday evening dirt track guys.
Yep.
Super good dude. And I know he doesn't want me to use his name because he sells more engines than he wants to. Right. He knows what to do with. He's like, Billy, if you make me sell more engines, I'm going to be in trouble.
Yeah.
But he calls me up and he's talking about, one of his guys that just a few years ago, he was running one of our profiles. One of the best profiles we had 5 to 10 years ago was our DSS solid roller profile for these dirt track late model type of deals. So he's got the best cam. And Glenn, sorry. So the guy sitting there talking to him goes, hey, I'd really like to upgrade your motor while it's here being refreshed. He's like, no, this runs good. We win a bunch of races. Finally, he goes, okay, well, I'll try it. So he goes and gets one of the new low shock camshafts that we've been running with this customer.
Yeah.
And what's going on is now his springs have gotten small, like his rings have gotten smaller, so his springs have gotten smaller.
Yep.
As the valve springs get smaller and smaller, they don't like being whooped around. They like to be treated a little bit nicer. So the low shock family of lobes with the new springs really calms things down. It lets you put some more backside area on the load, fills the cylinder better, we close it sooner.
Smoother landing.
Well, what's funny is so he's down, rural South dirt track race, and they have the national touring guys come through town. This guy has won a lot of individual races, but he's never been near the podium
with the big guys.
Yeah. They show up at his track. He comes in second. He said, with this new engine, he calls up our customers just like the text messages, the calls. He was the most excited he had been, I think, in his racing career, because he was able to run ahead of most of the touring guys and ran second to one of the best racers out there.
Right.
And it's funny. You go, well, Billy, is that the new low shock cam? Is that the new spring? No, it's really not. But what's cool is a package. This package that's modern, today's package, is better than 5 years ago's package. And except for one or two racers in the history of mankind, we're all a little bit of Dumbo. If you give a racer an engine that's worth 0.005 of a second a lap, and he feels that guy will be 1/10 of a second a lap faster.
Oh,
as soon as you figure something out that your package is a little better, that 1,000ths will make hundredths. If you can make something that's 100ths better, the guy will get up on the wheel and he'll be 10ths faster. Yeah. So do I think that the camshaft was worth, he was probably lapping this track that he's been at his whole life almost half a second faster than he's ever lapped it.
Wow.
The camshaft wasn't all that. But the whole package together really was able to give him the confidence to go up and run with these guys. And, man, it's one of the coolest things.
Oh. My dad's always said a faster engine always makes the car handle better.
No. 100%.
It always makes the car handle better.
No, you were talking to one of our friends who used to build motors for Rusty Wallace.
Yep.
And I remember, I'm like 51, but I started when I was like 24 right out of grad school. So I remember working with him. If you gave Rusty Wallace an engine that he couldn't feel 5 horsepower in his the batometer.
Yeah.
Is that what we got? The
batometer,
the dynamometer. But if you could give something that he could feel in the batometer, he would go out and win you a race.
Yeah.
They gave Rusty a car engine at Richmond one year that he spun out at Richmond, went to the back of the field, but he knew it was better, made up the lap under green, won that daggum race.
Yeah.
So these drivers, if you give these drivers something better, they will go out and win you a race.
Yeah.
Especially the good ones.
Oh, especially the good ones. Yeah. They know they have it.
They're going to go to the front.
Yeah, they're going to
get it. You had Smoke over there when you were at Gibbs.
Oh yeah.
You gave him some. If he thought he had the fastest car, he was honor bound to win the race.
I'll never forget the second time he won the Brickyard 400. Kevin Harper was out there. Harper and those guys were good back then.
That's where they changed the tire, and he had that mustache book.
Right. And so he's coming, right? And so Harvick's out there leading. Stewart's drumming down the front straightaway toward the end of the race. He keys the mic and says, "Here, kitty, 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 kitty." And it's like, oh, this is over. This is over. Harvick has no idea, but this is over. Stewart is so confident that even though he's half a straightaway behind, I can see him. Here, kitty, kitty, kitty. And it's like, oh, and he ran him down past him and went on.
Yeah.
And it's like, it's that confidence level. And like I said, anything that can give him that level of confidence is huge. I mean, I've seen it in my own career with my dad. Like, when I first went back vintage go-kart racing with Dad, it's like I knew I had the best stuff because Dad was tuning on it and building it. It was up to me to go drive it.
Yep.
So if I know the cart's capable of it, then it's up to me. Then you can go do it. So again, it's been a lot of fun stuff, and we both been fortunate enough to have a lot of cool friends.
You think that this happened in the 90s or this happened around mid 2000s? All of this is still happening in racing today. I mean, whether it's the top level, it may not be totally common knowledge, but basically, just like Ford told Roush and Yates they were going to have to play together.
Yep.
And that was in the early 2000s.
Yep.
And then they all got better, and Carl Edwards won that championship. Jeff Burton won a championship.
Everybody's good. Yep.
Everybody got good. GM this past year basically told Hendrick and ECR, you guys are going to play good together.
Right.
And Hendrick had a really, really good car. ECR had some things on the engine that were clearly better. Man, you gave that to
Kyle Larson.
Well, you gave that to Chase last year,
right.
And he went out and won, 3 out of the last 5 races. This year, you see they got Kyle Larson on it, and man, he is to the point where nobody wants to see any part of that car near them.
No, the 5 car is unreal right now.
They were on the radio saying, he's coming, get out of the way.
That's bad.
Yeah. He's coming, don't.
Yeah.
I know what you're thinking. Just don't.
Yeah.
Amazing.
Okay.
Amazing.
That was all 3. You got any more left? What do you got?
Yeah, no, I love it. We're 3/4 of an hour into this. It's been fantastic. Obviously, Hidden Horsepower available on Apple Podcasts, Spotify, SoundCloud, and occasionally live in our Facebook, YouTube, and our group. But Blake, you sent a video, and I want to get it in here of the mechanism camshaft. It looks like some sort of measuring device. I want Billy to tell us what's going on here.
Got the same size wheel as the lifter, and so when it's
start again, Billy. We couldn't hear you while it was running.
Okay, sorry. That's an AGCOL gauge. So the top probe that you saw, the wheel on that top probe is exactly the same diameter as the lifter wheel, and so what this is a vertical CMM. So you've got a rotating axis on the bottom, a dead tailstock on it. We run these vertically, the cam vertically, because you can actually see the sag of the camshaft if you do it horizontally. That probe measures 10 spots a degree, and it measures with a Heidenhain diffraction grating that can measure to at least 7 decimal places in inches. So you're taking a 7-place measurement 3,600 times around that camshaft. And you do it 3 times. You do an uppercut, a middle cut, and a lower cut on each load. And that lets us look at taper. Mm-hmm. It lets us look at the convex or concave.
Yep.
It lets us look at the frequency of it, because we can do a fast Fourier transform, look for things like anything that might be vibrating in the grinder. You can see a
chatter.
You can see a hydraulic pump that needs to be replaced from this. Something you could never see with your eyes when you do that measurement to 7 decimal places. And the head on the bottom has 2 Heidenhain diffraction gratings. And one time I took enough time to figure out, okay, it's a 12-inch head that can measure to a wavelength of light in 2 places. I got to 13 decimal places and just gave up and said, okay, that's of a degree, and said, okay, that's not minutes, that's not seconds, that's not milliseconds. I don't know what that is, but it'll be just fine.
It'll be all right.
But it's neat because AGCOL is the Addison Coal Corporation, and the only things that they make that I know of is engine measuring components for pistons, crankshafts, and camshafts.
Yep.
And they also make a lot of what goes in satellites for GPS.
Okay.
Yeah, so that's all they do is satellite stuff and engine stuff.
All I know is this. With an AGCOL and a profilometer, you can learn a whole bunch about oil.
Oh, absolutely. The AGCOL, it's funny. He's like, well, Billy, you said this camshaft measured, that it wore 1/10. How confident are you? I said, well, Blake, I'm confident it didn't measure 0.95, and I'm sure that it didn't measure 0.15, but 115. But I can't tell you whether that 10 is a 1104 or 11 996.
Yeah.
Because I haven't turned the next digit on, but I could if I did, because measuring it 3,600 times around you get just amazing data.
Oh, it was cool too to measure pre and post.
Yes.
And you could lay those graphs over each other and see. It was a really amazing tool. It just again, back to what one of the questions was earlier, was surface finish and all these things. These are the cool tools we got to play with.
It was so cool because I worked for Scooter Brothers for most of my first 22 years or something like that. We and I were having an argument, about I wanted one of these new CNC grinders. I wanted it bad, but we were still checking camshafts on a homemade checking gauge. And he's like, Billy, you want to make ball bearings and check it with a yardstick. And I'm like, well, it's more like a wood caliper, but whatever. And he looked at me, he goes, you can't make something better than you can measure it. And when you go for engineering classes on this, they'll actually tell you that the standard is at least 10 times. So if you want to hold a tenth, you've got to be able to measure to 10 millionths.
Got it.
Will people fudge it and go 7 times as much, not 10 times? Sure, okay, we can argue about that. But you have to be able to measure far better than you can make. So gauges like this AgCol gauge, as soon as we got the AgCol gauge, we thought we could hold lobe separation between like 1 degree. Well, our thing wouldn't measure it accurately enough. You got this, you're like, oh, hey, we can hold lobe separation within 0.2 of a degree. Who knew?
Right.
Same type.
That's a great rule, though, to kind of think about.
Yeah.
To measure something or to hold a tolerance, your measurement capability needs to exceed that tolerance by a fair margin.
If you go to a machine shop and you say, I need to make this widget and it needs to be plus or minus 1,000, and the best gauge he has is a Mitutoyo digital caliper, he can't do it. If he doesn't have something that can measure in the tenths, there's no way he's holding 1,000.
Right.
Because you've got to be, you can actually
you're at the error of the equipment.
Right, you're at the error of your measuring device. And I think people don't really appreciate just how important your measuring equipment, like if you go and look at an asset for a company that you want to do business with, they're all going to tell you, oh, we've got this 5-axis, 7-axis, they got this. You can skip over that and go straight to the back and find out what's their measurement equipment.
Yep.
What's their measuring equipment absolutely determines how good they can make a part.
I was able to go visit a manufacturer facility not long ago, and you walk around and see all this stuff, and you're like, yep. Got the QC department, you start looking there, it's like, now I'm impressed.
Right,
now I'm impressed with what you have for the QC department. They didn't just skip over that sort of rubber stamping parts. It's like, oh, you can really see something.
No, we saw it. Like if you go back and kind of circle around full 360, the NASCAR guys, you got to see when they got really good is when they embraced the quality departments. Yeah, you saw.
I hear Aaron White right now.
Yeah. No, you saw it. You saw that they were hiring engineers from NASA to do measurement at different cup teams. So it really changed the whole world.
Oh yeah, exactly. All right, Joe, what else we got?
Well, we got another measuring device, and flash it up on the screen. Billy, what's going on here?
Yeah, that's our Zeiss Profilometer, and that's the piece that can measure to 2 millionths of an inch. What they do to check this is they get glass planes and lay over it, and the glass planes are certified. They're just lap glass. And Mark will run it back and forth. We bought that whole system to Mark. What you're seeing it sitting on, the granite table, is actually an old CMM on airbags. And that was going on eBay. And I stole it off eBay, had somebody go around with a fork truck. And I had all the arms and stuff cut off with the torch before anybody could say no. But then we built the bed to put it on. But that probe, that's a skidless profilometer. You can see the arm that comes in and out. And the probe on there is literally, truly repeatable to 2 millionths of an inch.
Oh, that machine's amazing. I used it several times measuring camshafts, just like the one that was on there. And you could take the same measurement over and over again, get the same number. And that's where I really was first introduced to this by you. And It was like, it changed my whole world.
What we used to use are the pocket serves and the Mitutoyo like what Lake carries around. And those things are awesome pieces, and we love them. And they're neat because you can check a camshaft on the machine. But when you start grinding with a profile on the wheel, you need to measure the shape of that profile. And this is a skidded profilometer, so it rides along with the little ski and has the needle go up and down. The cool thing about that Zeiss is it's smooth enough that it can move in and out without needing the skid. So you don't have to have a skid. Once you don't have to have a skid, you can actually measure the contour of anything. And to give you an idea, when we measure a camshaft on that skidless profilometer, exhaust smoke and fine talcum powder, if you were to take 1 grain of fine talcum powder and put it on the camshaft, it would be over the scale of what the graph is. A human hair would be bigger than 10 sheets of paper that it's printed on. So, you know, what's funny is like somebody will check one and a little piece of dust will be on it, and you know, you get this call in the office, and like,
clean it again.
Just wipe it down and check it one more time. And they're like, hey, we checked it one more time, and that thing that was the size of the Empire State Building, you're like, man, the graph, a red blood cell would be off that graph. You know, like 1 drop of blood, not even a drop, but like just 1 little blood cell is bigger than the cell. So when you start talking about millionths, it really, you know, you start looking at there's 1,000 millionths in a tenth.
100 millionths
in 1/10 of a thousandth. So the smallest grade on a Brown and Sharp micrometer is full scale on the graphs we do with that.
That's crazy. Hey, Joe, doesn't Billy have this really great way making you feel really warm and fuzzy and comfortable and dumb at the same time?
Yeah, the dumb part, I definitely am getting that. And
it's like, oh man, I love hanging out with Billy. Man, I feel stupid.
No, but I want
to. Hey guys, I am a real nuclear physicist, but I'm also a farm boy from Mississippi. Both of those are equally true, so I can bubba down with anybody.
All right, there we go.
Well, I want to have beers with Billy at some point where we can ask dumb questions and it not matter. Because I got
PRI coming up December, Joe. We got to do it.
We're going to really do PRI this year.
It's going to do it. Oh, PRI is going to be on.
Yeah, man, I missed it so bad.
Oh, yeah.
Super excited. All right, a couple more questions, and then we're going to wrap it up. Like, Jeff is out there, and he feels dumb, too, but it's okay. He goes, I have a couple of small block Chevrolet. He wrote ABC, but it's a mistake. Small block Chevrolet roller cams that are fairly old school. Are the new generation low shock similar versions readily identifiable in the new catalog? Sorry for such a basic question, but talk a little bit about that. Old school stuff sitting around.
No, it's interesting because, you know, I probably get an email once or twice a day from customers saying, hey, I've been running this camshaft. What should I look at in a low shock? A lot of stuff with the small block Chevy stuff we see. We have a series of lobes called the LXT. I know that they're working on a new lobe catalog that has all the low shock stuff in it.
Okay.
I don't think it's published yet. If you have a salesman or somebody at Comp Cams, they can really help you with this. The low profiles, most of the small block Chevys are going, they're called the LXT profiles. The LXTs are like a modern version. Okay. The Dash 5 was like our most common high-tech lobes that people ran all the time. The LXT, the TCO is a new version of that. It's a modern version of and then the LXT is a low-shock version of the TCOs.
Okay.
So we have those in 405 lift, 440 lift. That's most common on your small block Chevys. But then we have stuff for hydraulic rollers. But as far as shelf camshafts, stuff you can buy on the shelf today, part number camshafts, we have that for all of the modern engines in the low shock, you know, your LS Hemis, Coyotes.
They're all
but the
LST.
small block Chevy stuff, the newest stuff, we don't have any part number camshafts to date that I can think of
that are low shock.
Okay.
But you can do customs though.
No, well, we're actually all these small, you know, you got a couple of 3-4 small block Chevys behind us. They've been all on the dyno this week, hydraulic roller small block Chevys that we've been running with in conjunction with Edelbrock, testing the stuff on a small block Chevy.
So it's coming.
Dude, can I tell you, it'll makes my little hairs think. Now I've got 6 hairs left and they're all standing on.
Okay.
It's going to be cool stuff.
Awesome.
But if you call up any of the comp tech line, the 1-800-365-9145 or something like
800
that.
cam help, isn't it?
I don't know what it is today, but or go to www.compcams.com. I think that still works.
Yeah, probably so.
If you ask them, say, hey, I'm running this camshaft, send them an email and say, what cam should I look at? They have all the lists. They can tell you about what lobes to look at. They'd be glad to help you. We've done a lot of seminars internally. All of the sales guys here are really up to speed, able to help you get what you want.
Yeah.
Excellent. Guys, this has been fantastic. As we wind it up, final thoughts from the two of you as we continue to evolve this conversation. This has been another great one, and I encourage the audience to just stay connected and keep trying to learn. But Billy, my question to you is, you've covered so much ground over the last 10 years, technologically speaking. What lies ahead? That's what excites me, hearing you talk and get so excited about what you've been able to do with all these measuring equipment and the numbers getting smaller and almost infinite, right? We can get as small as possible.
Yeah.
What's next? What's possible?
You'd think after 26 years of designing cams, I'd say, okay, well, man, my best year was 1996 or 2008 or, pick some year that something happened. But to be honest with you, today is the most exciting time in motorsports. We're starting to really learn how to put everything together. When we were merged with Edelbrock, I start looking around and like any family when it comes together around, you get your family comes together, comes down to Thanksgiving, you look around, okay, you look at the new guys, go, okay, who's the Uncle Eddie?
Right. Yeah.
Man, I look around for about 15 minutes. I realize I'm Uncle Eddie. But this has been a cool deal as we get together with cylinder heads and camshaft and working together with packages. I'm loving that. The stuff we're learning on hydraulic rollers is amazing. You got people out there running 8,000 RPM. That Ilmore motor I talked about, that's a 8,000 RPM all day long, races after race. Hydraulic roller based LS.
That's crazy. I didn't realize it was hydraulic.
Yes, that's a hydraulic roller camshaft.
Wow.
Yeah.
And it is a reliable engine.
Oh, they've
got it. I see it.
You basically have to run it to win to be competitive now, because they let you guys build the motors against it. You could take a spec race motor and run against this spec motor. And the way the rules were, you kind of had to go with the spec motor. You see SRX deal. I'll tell you, all of this is coming together. There's so much going on. I hope we have a ton of new stuff to release at PRI this year. From my point, I'm always looking at PRI next year, and I can tell you that I'm super excited about what's coming up for 2022. I'm super excited for 2023. I am really excited for 2024. There's so much coming out, and really it's just how quickly we can verify all our test results, get manufacturing lined up, and get everything going. There's amazing products that are going to come out each year. I'm more excited. And one of the things I wanted to thank you for, Lake, is you have a passion. You guys both have a passion for communication, for getting things going. When I was a kid, we used to go to the Antlers Hotel in Colorado Springs for the Advanced Engineering Technology Conference. AETC. And I'm so thankful that we're taking the spirit of that. And Ben's been pushing it out there in his deal. You guys have been, Hidden Horsepower has been an amazing deal.
Oh, that's what the whole Engine Performance Expo is the ethos of let's keep what the idea behind AETC going. And this year, our good friend Harold Bettis passed away. We'll miss him. But I'm so glad that his passion is going forward in everything you guys are doing. And really appreciate that.
And really, guys, anybody's watching this, I don't want to grow up and have to get a real job. You guys don't want me designing bridges, because I'm too I wonder what this does. I wonder what this does. When bridges fail, it's bad. Everything we're doing, we're testing here. This is a real job. We're like Peter Pan. We don't want to have to grow up and become adults. Let us keep playing, and we're going to help you do everything you can to enjoy your hobby, enjoy your passion, to win races, to have a blast, and really just make this the most exciting time there ever has been in performance engines.
And like you said, the change here recently in professional motorsports towards longevity really is a gift to the whole of the aftermarket. Because now the whole idea of, well, how much power does it make? All right, but how long is it going to last? This idea that if I make more power, therefore I'm giving up durability, that's just not the math anymore.
No.
The equation has changed. You can make more power and increase durability because of what we've learned with surface finish, what we've learned with metallurgy, what we've learned with coatings and lubricant technology, all of those things together in that right combination.
Right, and the dynamic stuff we do here. I mean,
Yep.
you know, it's funny, as you look over here, and there's going to be 3 Spintron rooms, 1 dyno room.
Yep.
Then there'll be 3 Spintron and 2 dynos.
Train here coming.
Yeah, we'll get another one set up. But, you know, the testing that we do here is just, you know, if you go back to the 80s, people just design parts and throw it out there and let the customers be the testing and the customer be quality. Today, we have a tremendous quality department. We have more testing engineers than you can shake a stick at.
Well, it's not just taking the cam, throwing it in the dyno, making a couple hits. Oh, that made 30 horsepower.
Yeah,
that's going to go sell. It's like, no, we're going to make about 30,000 coals on it, and let's see if it still holds together or not.
And that's why I can tell you stuff about, I know what's coming out this year at PRI.
This one's on the closer track, isn't it?
Yeah, it's on the closer track, yeah. Another train. I'm getting used to them. But yeah, the whole deal, life is changing so quick. And like you said, you know, whether you're a bracket racer, whether you're a Saturday night dirt track racer, where you go wine and cheese and turn right and left with me, you know, whatever type of racing you're in, whether you're out there on the street, the quality of the parts and the performance potential, even in the past 5 years, seems to have doubled. And it's going to do nothing to get better going forward.
Well, what I say is, what was NASCAR level technology 20 years ago, you can go buy right now.
No, absolutely.
I mean, it's like the best stuff that was out there 20 years ago, you can go buy it right now, and it is infinitely better than the normal stuff people think they have to buy. It's like you can buy the iPhone. You don't have to have a flip phone or a pay phone. You can have the higher level technology, and it's actually going to last you a lot longer so that you can get performance and durability. You don't have to compromise. That's the great thing. There's really, with the technology, because of the testing and all that, you don't have to compromise when you put together the right combinations.
And even some of our young engineers, you know, they're fresh out of college, they still have some debt, they're not making a pile of money right now. We've been talking to them, and they've been spending more money, especially like on their short blocking engine, because you can spend a little bit more money if you know this is an engine that you're going to, you know, when we built engines as kids, they're like disposable razors. You know, you got one out of the junkyard, you ripped it down, you put it back together, and if the thing was still together in 12 months,
when?
Right. Today, you know, it's nothing to have one of these engines you put together. You might have this engine for 20 years and never have to go.
It should last.
Right.
I mean, I think about Kevin Studecker at Total Seal. He's done the Hot Rod Power Tour and Drag Week and stuff with the
administrator came by my house in that car, going to Power Tour, stole my hat. Did give it back.
That's true.
You know,
that
hat's been everywhere.
It just runs.
Right.
That's like an 800 horsepower engine.
Yeah.
And it just runs. He'll take it out and go down to the Taco Bell sometimes and stuff. So
big white station wagon, drive it all over everywhere. Has an LS7 on it.
Oh yeah.
It is a bad piece.
It is a sleeper of sleepers.
Oh, dude. Right, because you think it's fast, but you think it's 13-second fast, right?
Yeah. No. It's
way
faster.
Way faster than that.
Yeah, so it's like, okay, it's anyway, fun stuff. So,
gentlemen, this show has been fantastic. You guys have been great. Lake, final thought, and we'll get up on out of here as the train is driving on by.
The train keeps on rolling, right? There's a song about that.
Yeah.
So anyway, I thank you, Billy, so much for allowing us to come in and do one of these live episodes. And for me, for everybody who knows, this is home. This is my old home, and it's great to be here and see everybody, and to be able to bring everybody back here to the R&D lab and let you talk to Billy a little bit and kind of see what's happening here with Comp and Edelbrock and what's coming together, because these are exciting times in the industry, and we want to, in that spirit of the AETC, is keep sharing actionable information so that people in this industry can really have fun.
Yeah, I mean, we talk about wanting to have data to make a decision on a product. I think it's good to share what goes into these products so people can have data when they make their buying choices and when they figure out what to do too.
Because with that good data, you can make good decisions, and then you can go have more fun. Because the worst thing is that moment of indecision, of not knowing and having to kind of guess at it. There's never any fun with that.
No, it really is.
Gentlemen, great job as usual. Billy, thank you so much. This has been a fantastic episode. Really appreciate both of you. You know, at the fact that you're a nuclear physicist working in auto racing and engines, like, I think that's great. We got one. It's awesome stuff. Appreciate it. Gentlemen, thank you so much for all you've excited everybody out there, and it gets better and better each time we get you together. So this has been a great one, and thank you so much.
Hey, thanks for having us.
Thanks, Joe.
Thank you very much. There they go. Billy Godbold, Lake Speed, with us here on Hidden Horsepower. Of course, the podcast is key. Apple Podcasts, Spotify, SoundCloud. You can get there from the TotalSeal.com website. It is awesome. We've got new episodes dropping all the time. We would love if you would write us a review. Tell your friends. If you're watching out there on social media right now, especially YouTube or the others, share the show. Tell your friends. Copy and paste. Send to others who might be interested in this, because it's all about information exchange. These guys have got the passion, they've got the knowledge, and they want to share it. And that's why we do the show. It has been tremendous. And everybody out there, like for instance, Chuck Lynch out there, the Godspeed Show, Prosperous Power, absolutely love it. Chuck was one of our guests on the Hidden Horsepower podcast. Also, it has been tremendous. I do a show called WFO Radio when I'm out there on the NHRA tour talking to drag racers. Spoke with John Force just the other day. You can go check that out as well as you peruse the social media. But I thank all of you folks out there, and thank you so much for joining us on this episode of Hidden Horsepower. Other episodes, Jason Line, Pat Musey, John Kazi, many others. You can check them out. And this episode will be available on the podcast, audio only, very, very soon. Thanks to Billy Godbold. Thanks to Lake Speed. Thanks to the conductor of the train in the background. It was awesome. My name is Joe Castello, and we'll see you next time on Hidden Horsepower, presented by Total Seal. Brought to you by Total